In this video, we're looking at a laser beam that's incident on a container of water. It refracts into that water and then encounters a slab of glass submerged in the water. Part of the laser beam reflects off of that glass and part of it is refracted into the glass. And what we're looking for in this problem is these angles, theta 1 and theta 2. Theta 1 is the reflection off of the glass. Theta 1 is the angle of reflection off of the glass, and theta 2 is the angle of refraction into the glass. Now, of course, these are both Snell's law problems, but there's a little bit of geometry to work out first. That angle of reflection off of the glass, theta 1, that's the same as the incident angle coming into the glass. That's the law of reflection. Then I can see that theta 1 also occurs here as the angle of the first refraction into the water, because those are alternate interior angles. That allows us to use Snell's law to obtain theta 1 from the incident angle of 45 degrees at the surface of the water. So we write down Snell's law for that first refraction, and I have the index of refraction of air, sine of that incident angle in the air. I'll call that theta A. That's equal to the index of refraction for the water, sine of the refracted angle into the water. Now that refracted angle into the water, that's theta 1. We go ahead and plug in the index of refraction for air, that's about 1. The incident angle, 45 degrees. The index of refraction for the water, 1.33. And then the refracted angle into the water, theta 1. Well, the only unknown here is theta 1, so we divide by 1.33 on both sides, and then we invert the sine function. We take the inverse sine. And this gives us a refracted angle of about 32.1 degrees. And we've already figured out that's the same as the incident angle onto the glass, and it's the same as the reflected angle off of the glass. So in part B, we want the angle of refraction into the glass. And in part A, we just found the incident angle. So we apply Snell's law again. And here I'm using a subscript of W for the water and G for the glass. And we plug in the index of refraction for the water, that's 1.33. Sine of that incident angle, which was theta 1 or 32.1 degrees. And then the index of refraction of the glass, that's 1.5. And the refracted angle into the glass, that's theta 2 from the diagram. So again, we just divide by 1.5 and invert the sine function. And when we run the numbers on this, we get 28.1 degrees for the refracted angle into the glass, and we're done. If you enjoyed this video or at least found it useful, check out another one by clicking one of the links on the left, or click the Slab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Zach's Lab, and best of luck on your math and physics journey.